Nanotech triples algae oil for next-gen biofuel production. Key takeaways. UTEP researchers increased lipid content in chlorella vulgaris by introducing zinc oxide nanoparticles at precise concentrations. The lipid boost stems from a cellular stress response. Doses above 50 milligrams per liter reduce cell health and overall fuel viability, highlighting the need for precision. Future work targets broader applications using saltwater and wastewater-tolerant algae, aiming to reduce resource inputs and enable large-scale deployment. A new study led by UTEP's Department of Chemistry and Biochemistry reveals a promising method for dramatically increasing lipid production in chlorella vulgaris, a fast-growing freshwater microalga already used in biofuel development. Researchers introduced zinc oxide nanoparticles into cultivation environments at controlled concentrations between 30 and 50 milligrams per liter. The result? Lipid levels in the algae jumped from their standard 14% to as high as 48% of total cell mass. That's more than a threefold increase in oil content, offering a potential breakthrough for the economics of algal biofuels. Assistant Professor Hamidreza Sharifan explains that the boost comes from a stress-induced response. Sometimes when people are stressed, they gain weight or, in other words, accumulate more lipids. We found that a similar thing happens to the cells of the microalgae when we induce stress, in our case by exposing them to zinc oxide nanoparticles due to the effect of reactive oxygen species. The effect is highly dose-sensitive, while moderate nanoparticle levels significantly enhance lipid accumulation without harming the cells. Higher concentrations over 50 milligrams per mets led to oxidative damage and a drop in biofuel quality. This stress-based method, when carefully controlled, offers a viable way to improve yields without sacrificing cell health, a critical factor in making biofuel production more commercially attractive. A new evaluation tool targets commercial scale-up. Beyond increasing lipid concentration, the UTEP team developed a biofuel suitability score, BSS, a framework designed to assess multiple variables involved in algae-based fuel production. The BSS helps guide decisions on how to fine-tune cultivation for real-world application, accounting for both yield potential and production stability. This added layer of analysis positions the work not just as a lab success, but as a meaningful step toward commercial viability. By improving predictability and scalability, the research helps address one of the biofuel sector's major hurdles: low and inconsistent oil output from algae. Long-term, the researchers aim to extend their technique to other microalgae species that can grow in less pristine environments like saltwater and wastewater. This would allow future biofuel operations to scale without relying on freshwater, aligning with broader goals around resource sustainability. The project, supported by UTEP's U.S.-Mexico Collaboration Fellowship and USDA funding, was conducted in partnership with Universidad Autónoma de Chihuahua and lays the groundwork for further industrial application in renewable energy transition, and industrial digitization. You've been listening to Sustainability Soundbites from E+E Leader, where the business of sustainability meets real-world impact. Thanks for being a loyal listener. To inquire about brand partnership opportunities, reach out to a member of the E+E Leader team.